Why is the working fluid so important for the Rankine cycle? Imagine a system that turns heat into electricity, like the power plants that light up our cities. The secret behind this process is a special liquid called the working fluid. It might seem simple, but it plays a huge role in how well the cycle works. The Rankine cycle is a way to generate power by heating a liquid, turning it into vapor, letting it expand to produce work, and then cooling it back down. The choice of working fluid is what makes this process efficient or wasteful. The working fluid absorbs heat in the boiler or evaporator, changing from liquid to vapor. This vapor then expands through a turbine, creating energy that can turn a generator. After that, it cools down and condenses back into liquid from before being pumped back into the boiler. The key is that the fluid's properties determine at what temperatures and pressures these phase changes happen. If the fluid vaporizes at too high or too low a temperature, the cycle becomes less efficient. Water is the most common working fluid because it has a high latent heat of vaporization. That means it can absorb a lot of heat before turning into vapor, making it great for large power plants. These plants produce about 85% of the world's electricity. But water isn't always the best choice. When heat sources are lower than 150 degrees Celsius, organic fluids are used instead. These fluids boil at lower temperatures, so they can work with waste heat or renewable sources like geothermal energy. Organic fluids have different molecular properties that influence how fast turbines spin and how much mechanical wear occurs. They often cause turbines to rotate more slowly, which reduces erosion and extends equipment life. The thermodynamic characteristics of the fluid, like boiling point, critical temperature, and pressure, help match the cycle to the heat source. Picking the right fluid means less energy is lost during heating, expansion, and cooling. In short, the working fluid is vital because it sets the temperature and pressure limits for the cycle. It helps match the heat source and sink, making the process more efficient. It also impacts how durable and reliable the system will be over time. Different fluids allow the Rankine cycle to adapt to many applications, from huge power stations to small waste heat recovery systems. Choosing the right fluid is the first step to making sure the cycle performs well and produces electricity efficiently.